This is Mark here again. I'm going to give you a quick once-over on SimuHydro. SimuHydro is right next to SimuGas. It's the boiler software that we're going to be utilizing for the next 3 weeks. This week you'll have an assignment with it. So you just hit launch and it will open up SimuHydro. You could sign in. I'll just log on as instructor. And I just want to show you a couple things. So we're going to run normal. Run normal will give you the boiler in its normal situation. We can turn on the power. And we can turn on this. That's the circuit breaker. This is the main switch and the gas control's on. So room temperature's there. We can lock the room temperature. And let's turn your time up 10 to 1. So what else do we have here? There, it's lit. Now, the difference between a boiler and a furnace, if you don't know this already, is a boiler will stay hot. And the burner comes off and on, not based on the thermostat, but it comes off and on based on the temperature of the water. So let's just take a look at temperature here. The temperature of the water is 170. At 180 degrees, that burner should shut off. We're at 170 right now. It might stay at 170 based on what's going. You can see the bubbles here showing you the flow. The hotter the water, the redder it is. Comes around, it's going through a couple rads all the way through. This is the circulator, the pump, and back in through the boiler. This is the burner, so you have the valve train, the burner. We have a gas shut off, and we have what's called an intermittent pilot. So the pilot is lit. It's not a thermocouple, and then the main burner is lit from the. So it's called an intermittent pilot. So you'll see a bunch of scenarios here. You'll see the red. This is your cold water supply. This is the water in, backflow preventer, pressure reducing valve, cuts the pressure from 60 psi to 12 psi, and the system's going around. Let's take a look at the electrical side of it. On the 120 volt side, you cannot get more simple than this. We have a circuit breaker, a main switch, and this is the circulating motor. If we're not sure what these say, we can just open these up here. CCM, circular control switch, they call it. That's this guy here. That will close when the boiler gets to a certain temperature. What temperature is that? Come down here. It is the circular cuts in at 110 degrees. So at 110 degrees, this closes, turns the circulator on, which is this guy right here. That moves the water around. When the water's cold, that guy's not going to circulate. On this side here, it's a little bit more cumbersome. So we have R and C. C is connected to all the loads. This ignition module is a load. That number 5 is a C. The number K1 here is a load. M1 is a load. That's C connected to it. The light is a load. This light is a load. This entire box here is called the vent damper. And it's a sequence of operation that basically opens and closes based on whether it's got power or not. So let's go through a couple other things. This is the low water switch. If the water gets too low, this guy here will open up, cutting the power, going to everything through this way. So R comes through this way and goes to the ignition module. R also comes through this way. This is R and W. This is your switch for your thermostat. This is your heat anticipator. That's what we call a high limit switch or operating aquastat. So this opens and closes based on whether the unit gets too hot or not. This one is called the block vent safety, BVS. And this is FRS, I think is a fuse. FRS. Oh, sorry, a flame rollout switch. So there's your flame rollout here, and so these are both switches. This one's a fusible link, actually. This one doesn't open and close. It just opens, and you'll have to replace it. On this ignition module, we can actually measure between these numbers. If you take a look at here, we can actually measure between 2 and 3. So we have 24 volts there. That means that the pilot valve should be open. The pilot valve is obviously open because I have a pilot, intermittent pilot. We could also check, if we double click this guy, we can check terminals 3 and 4. Okay, 3 and 4 tells me that there is a C here and the R is through here. These are triple switches here that open and close based on how this vent damper works. And I might do a separate scenario on this vent damper. I think I will. I'll do a separate video on that, or I might teach that one live actually. So I'll give you guys an idea of what's going on here. So this is basically a boiler system. Now, the electrical part of this boiler is pretty simple, not like a furnace. This is the mechanical side of a boiler is the one more that's harder to troubleshoot. We could have too much pressure in the tank, could have too much pressure reducing of the valve, pump might not be working, we could be leaking out of the relief valve, or you could have something with the gas train going. So we got a couple scenarios here. So for your assignment this week, I'm going to ask a bunch of questions about this boiler. You're going to go through across the top here, understand what's going on. We have a manometer. We have, this is a thermometer. This one will give you an idea of some things that you can take a look at, like the pilot. Tells you what a good pilot is. That's your diagnostics, which you're not going to use yet. These are to close the main gas valve. So these are all the valves that you open and close. This here is your relief valve. You see I just hit it. Now I got hot water coming out of my relief. Turn that off. And that's my primary air adjustment on this side. On the electrical side, you guys know most all of these. We've dealt with them except for you're able to open and close valves on the electrical side. Volts, ohms, amps, ignition module. So again, I'll ask you questions about all this. So that is an introduction, quick introduction, 8-minute introduction to SimuHydro. And again, I'll ask you a bunch of questions and you guys can answer those. Great. Thanks. And we'll see you next week.